Hi, so welcome to my video on testing in software engineering. It's going to mainly talk about unit testing, among other things. This is just a final presentation for my software engineering project. And let's just get started with it. Okay, what is testing? In software engineering, testing is a crucial process that involves evaluating a software application or system to identify any defects, errors, or bugs. The primary goal of testing is to ensure that software meets the specified requirements, functions as intended, and delivers a high level of quality to its users. Types of software testing. Software testing has various types of testing techniques, each serving a specific purpose in ensuring the quality and reliability of software. There are many ways to test software, but for now, we'll be going over unit testing. This is just a graph of all the ways of software testing. So we're mainly going to go over this guy right here. So we have unit testing. What is unit testing? Unit testing is the practice of examining discrete code segments by testing the smallest working unit of code. Unit testing serves the objective of confirming that every software unit operates as intended and complementary with its design and requirements. Characteristics of good unit tests include isolation, automation, it's repeatable, it has fast execution, and white box testing. So we have isolation. Writing testable code is critical for performing a good unit test. Code may be readily tested in isolation by separating object development and business logic, and utilizing dependency injection. The purpose of isolating your tests is to generate stable tests that provide the same results regardless of when, where, and what sequence they run in. Creating reliable tests is not easy, however. It is not difficult to accomplish, and there are significant advantages to developing reliable testing. So here are the benefits of isolating code. 1, it helps identify bugs and defects early. 2, it's focused on testing. And 3, it facilitates refactoring. And 4, it enhances your code's quality. First, we have automation. Unit tests are frequently automated, which means they run without human interaction. Automated unit testing frameworks such as JUnit for Java provide tools and modules that make it easier to write and run unit tests. Another characteristic of unit tests would be that it would be repeatable. Unit tests should be repeatable, which means they give consistent findings when run again under the same conditions. This enables developers to rapidly find and debug bugs by rerunning tests after modifying the code. Another one would be fast execution. For a characteristic of unit tests. So unit tests tend to be quick to run since they focus on evaluating tiny blocks of code in isolation. Fast execution allows developers to run tests often during the development process, allowing for quick feedback and iteration. And white box testing is when unit tests is sometimes seen as a type of white box testing, since testers have access to the internal structure and logic of the code under test. Tests are also developed based on the understanding of the code's implementation specifics. So we're going to go over Java unit testing in JUnit. Unit testing in Java is a means of ensuring that code is operated as intended. It entails testing distinct code segments like classes or methods to make sure the desired outcomes are obtained. JUnit is a popular open source testing framework for the Java programming language. and it is primarily used for writing and running unit tests to ensure that individual units of source code are working correctly. Unit tests are small, focused tests that verify the behavior of the specific part or unit of code, such as a method or a class, in isolation from the rest of the application. So, what is JUnit? JUnit offers a simple framework for creating and performing these tests. It provides assertions, basic unit tests, and exception handling that assist developers in defining tests, running to them, and reporting the results. JUnit automates the testing process, allowing developers to find and repair errors earlier in the development cycle, resulting in more robust and dependable software. So first, we have assertions. Assertions are used to verify that certain conditions are true during the execution of a test. For all primitive data types, including objects, arrays of primitives, and arrays of objects, JUnit has overloaded assertion methods. In the assertion statement, the expected value comes first, then the actual value. In the event of a failure, the first parameter may optionally be a string message that is utilized as output. Okay, second, we have basic unit tests. Basic unit tests are mostly performed with JUnit. JUnit's ability to create tests that don't require human interpretation is one of its advantages. The intended outcome is determined when a test is created. Next, we contrast that with the actual outcome. We can be sure that the test was successful if they are identical. And if they are different, we must go back and correct the problem. The ease of running several test cases concurrently is another advantage. And we have exception handling. Not only do we need to test a program for situations when things go right, we also need to make sure we handle things correctly when they go wrong. That's where exception handling comes in. JUnit offers tools to guarantee that anticipated exceptions are raised when a test is running. Let's look at an example. So this is one of the examples that is in one of the sources for the LinkedIn Learning Java testing with JUnit of exception handling. And the next slide is going to explain the following code. In this example, the code tests Java's exception handling using the exception handling test JUnit test class. The test main and the test divided by 0 are the two test methods that are present. The test main test if an index out of bounds exception is thrown when trying to access the first element of an empty array list. The test divided by 0 checks to see if dividing by 0, 10 divided by 0 results in the throwing an arithmetic exception. These test methods indicate that a certain exception is anticipated to be raised during the method execution by using the expected property of the test annotation. The test fails if the method is executed without throwing the required exception. We have another thing called ignoring test. Another feature that JUnit has is that it allows you to temporarily ignore tests. So if we ignore the test annotation in JUnit from our previous example, the exception handling test, it will become a simple Java class. Another feature that was added to JUnit is the ability to execute tests using parameterization. You may run the same test with different pieces of data using JUnit's parameterized testing feature. When you wish to test a method with varied inputs and predicted outcomes, this is helpful. This is how it operates. Now I'm going to show you another example of a parameterized test in one of the following codes. This is right here. another code from LinkedIn Learning, this following link here. In the following code, the JUnit class parameterized test serves as an example of parameterized testing in the framework. The test method test_add2numbers may be performed several times in various parameter values defined in the data method, because the run with parameterized class annotation specifies that the class utilizes the parameterized runner. So we're going to talk about test-driven development. What is TDD? Test-driven development, TDD, is a technique for building software that guides software development by writing tests. It was developed by Kent Beck in the 1990s, in the late 90s to be exact, as part of extreme programming. In essence, we followed 3 simple steps repetitively. 1. We write test for a bit of functionality you will want to add, right here. And 2, you write the functionality code until the test passes. And 3, we refactor both new and old code to make it well structured. So we have this following graph here. It has write a list of test cases, then pick one test, and then write the test if it's red, and then if it's good, it'll pass, and then it'll be refactored, and then you'll start that circle over again. We can update the list as we learn, so that's pretty good. Why is TDD important? It's the first and most effective defense you have against software flaws is your testing. Tests are equally necessary as the implementation itself. It greatly reduces bugs. TDD can encourage more molecular designs, and it can reduce code complexity. So we have 5 questions that every unit test must answer. Let's go over the 5 questions. 1. Does the test confirm that the tested code acted as predicted in response to certain inputs or conditions? This question checks to see if the tested code operates as intended in certain scenarios or inputs. Does it handle edge cases properly? An edge case is a problem or a situation that falls outside of normal procedure and is on boundary of your operating framework. Testing these guarantees that the unit handles unusual and unexpected inputs accordingly. Does it handle errors with grace? Testing error handling makes ensuring that when mistakes or exceptions happen, like incorrect inputs or unexpected states, the device reacts accordingly. Is it isolated from external dependencies? To guarantee that errors are limited to a specific area and that tests are repeatable and predictable, unit tests should isolate the unit they're testing from another dependency like databases, networks, or file systems. Okay, and our last question would be, does it cover all the following scenarios? Unit tests should include a wide range of scenarios, such as common use cases, corner cases, and unusual circumstances. By answering these questions, unit tests contribute to ensuring the accuracy, maintainability, and dependency of your code base. So what have we learned? The foundation of software engineering is testing, which guarantees the dependency and quality of software products. It is a methodological procedure that entails running an application or software with the goal of identifying bugs and problems. Software quality is ensured in large part by testing. Nowadays, with software being used in many different sectors, it is crucial to make sure it is reliable, useful, and secure. Software developers can find errors and malfunctions through testing that could otherwise affect the user's experience or potentially cause system breakdowns. Furthermore, throughout testing, boost the software's product's legitimacy by inspiring trust in all its parties involved, such as investors, users, and regulatory agencies. Software engineering tests come in a variety of forms, each with a distinct function, and in this case, we talked about unit testing. Unit testing is the practice of examining discrete code segments by testing smallest working unit of code. Every unit undergoes independent testing to ensure that it performs as intended in accordance to the criteria. These tests are repeatable, automated, and should ideally be run regularly during the development phase. Unit tests also encourages code reusability and modularity. Testability conscious code. Let me repeat that. Testability conscious code is typically more modular and loosely connected, which facilitates understanding, maintenance, and reusability in other systems, components, and future projects. To sum it up, unit testing is an essential software development technique that helps developers find bugs early on, maintain and improve the quality of their code, and build trust within the code base. Teams may produce a highly quality software solutions that satisfy users and ensures difficulties of the constantly changing digital ecosystem by adhering to best practices and including unit testing into its development workflow. It's just my sources from my PowerPoint today. And that's it. Hope you enjoyed the video.